Hi there, my name is Anirudh Koul, and I'm really excited about the world of visual question answering. Not just because the results look magical, but because of the insane value it can open for a group of people, the blind community. Today I'll be sharing some stories of what happens when promising research from conferences like CVPR ends up in the hands of real people, like in the blind community, and how it can significantly impact their daily lives. By sharing some learnings and mistakes, hopefully your journey of converting research to production gets accelerated and you keep making the world a better place. To introduce myself, I work as an AI scientist at Pinterest, helping employees incubate emerging technologies. Previously had the good fortune of starting a team at Microsoft, which built one of the most used apps amongst the blind community, the Seeing AI app. I also worked at an assistive startup called Ira, which connects the blind community with the remote visual interpreters. In my free time, I run a citizen science accelerator in collaboration with NASA called SpaceML, working from AI for climate change all the way to planetary defense. And for something more exciting, I run a team at Carnegie Mellon, which competes at the Robo Race Autonomous Racing Car Championships, running this car at 175 miles per hour and getting to the podium. And for all the mistakes and learnings during this journey, I compiled them all in a book. So let's get it going. Look, the world is full of gaps. Gaps between what we want to do and what we can do. Some gaps are small and temporary, others more lasting and profound, but we all experience them. And technology is here to fill the gaps between our ability and our task, to make us efficient, to open doors to new opportunities, to give us superpowers. But the challenge here is creating the right tools to fill those gaps. When my grandfather started to lose vision with age, when he couldn't read the books that he himself wrote, when he couldn't recognize my face over Skype calls anymore, it got me looking into tools that could assist him. I looked around but was shocked to see the state of many of those technologies. I mean, we live in a day and age of self driving cars. Strangely, many of those tools felt decades old. Well, when you can't find a solution, you do the next best thing. You go build it. So I got started, met a group of like minded folks, and we set out to explore the area of computer vision for the blind community. Our first prototype, built at a week-long hackathon at Microsoft, was this MacGyver-styled talking cell phone duct taped to the head. I think you would agree. Nobody has ever accused geeks of being fashion forward. You could talk to this, ask questions about your visual surroundings, and hear descriptions. We included all the buzzwords for 2015: slang, VQA, object detection, captioning, but more importantly, built an audio experience around it to interact with it. It looks impressive, but I must confess, many of those things would take more than 90 seconds even to get a simple response back. We luckily had experts like Margaret Mitchell, Ross Gershik, Ishan Mishra on the team to get things rolling. Once the hackathon finished, the team kept working in the evenings and weekends to see how far we can take it. This evolved into a smart glass prototype with a camera. You would press a button, it takes a photograph, figures out what your intent might be, and then gives an audio description back. With a polished working prototype, it started to attract a lot of attention and support. So we started asking ourselves, how do we get it in the hands of as many people as possible? And the answer was pretty simple: a free smartphone app. So the team got Microsoft CEO's blessings in the form of funding, took it to an 11, and a year later released Seeing AI, the talking camera app for the blind community. Talking camera, it speaks what it sees. It's like a Swiss Army knife. It's small, portable, and has dozens of handy uses. For example, you can already see how excited I am talking about it. But if you couldn't, this app could help.
One face near center 5 feet away. Eugene near center 5 feet away. Process 37-year-old male with a mustache wearing glasses looking happy.
It detects faces, announces where they are on the screen, to the left or right, how far they are, 1 feet or 10 feet. And once the photo is taken, predicts the gender, age, and even the emotion of the person it sees. I know it sounds a little gimmicky, not the most accurate, but getting some idea of the visual description can be pretty valuable for, say, small talk. A blind salesman used this information to change his sales pitch based on what the app is telling them about their client's physical response. The app can do more, like real time face recognition. Simply take three photographs of your friend and it announces their name the next time it sees them. For privacy, we do this all on device, from training to inference. But on device is code for fast, real time experience, which can be pretty valuable. For example, a professor had photographed the faces of her entire classroom, put the phone on a desk with our app running, pointing towards the classroom door. And now, students cannot sneak in late to the class anymore because the names are announced as they enter. Pretty busted. No more tippy toeing anymore. Our creative users, being creative, figured out another use case for face recognition. Turns out there's a guy named Mr. Lincoln who appears in the center of a $5 bill. So why not teach the app his face to recognize the $5 currency bill? Well, we got the bait and understood they need a currency recognizer, so we built it.
$5, $10.
Runs pretty fast. The famous blind jazz musician Ray Charles always insisted in being paid in single dollar bills so that he was certain he wasn't being cheated on. Exchanging money is exchanging numbers to most of us, but for the blind, it's exchanging trust. And with this app, Ray Charles would have to worry no more. Now, if it can understand faces, could it learn more? Like what your body is doing, what objects are around it, and how is it interacting with the world? That's the next experience.
Processing. A man jumping in the air doing a trick on a skateboard.
Now, image capturing is not going to surprise anybody in the audience. But the key here is that if you want your experience to run in production, you need a much larger taxonomy of objects than what Coco had, and common interactions which are not as glamorous as doing a trick in the skateboard. Now, you can go one step further and add object detection on top of it. So if you move your fingers on the screen, you could understand the location awareness of the experience.
Processing. A person sitting at a table with a laptop in a living room. Processing. 6 items detected. Move your finger over the screen to explore. Table. Laptop. Pillow. Couch. 38-year-old man with black hair and a beard looking neutral. Couch. Pillow. Couch.
Now, could localization be taken to the next level? Yes, with spatial 3D audio. The new iPhone 12 has a LiDAR sensor for understanding the depth. And if you mix this depth information with 2D object detection and project it back in the 3D world, you can understand where these objects are, how far, and in which place, and remember them. So Singia team launched an experience where as you move your phone in your world, you can hear the audio of the object coming from the direction that it's located in. I can't show it to you in slides, but you can experience them if you have an iPhone 12 Pro. Now, the day after we launched, we noticed something incredible. Blind community started posting photos on Facebook that they took of themselves. Yeah, you heard that right. Blind photographers. Because of the app's live guidance, when they meet a friend in a social occasion, they can frame the friend's face in the center of the screen, know that they are not too far away, and if they are not smiling, scold them a little bit and retake the photograph. After all, who doesn't want smiling photos on Facebook? What else can it do? It can read text in real time.
130.
And real time is beautiful for the blind community because when you don't know where the text is to begin with, you can scan, say, a hotel room, find important notices like the exit route or the thermostat. Some people were startled. They never knew how much text was around them. Some people sat in the back of cabs, pointing the phone outside to discover new shops that have opened in their neighborhood.
The Alameda. Chipotle Mexican Bill. Office. FedEx office.
One American blind user put the phone on a tripod, pointed it towards their television screen, and started watching Korean movies.
이름이 뭐야?
Someone's coming. I'll look into it and text you, baby.
Because the app was reading the subtitles in English. But some information may be written by hand, so we also worked on it. We released it in December. December means Christmas, Christmas means greeting cards, and suddenly Twitter went ablaze with users saying they are reading a greeting card for the first time in life. Someone reading a love letter they had received before they had gone blind. Someone read their kids' homework for the first time, and for the first time scolded them because they knew the homework isn't done. So let's take a closer look at the design. A simple but important use is recognizing products. Imagine trying to tell the difference between a can of Coke and Sprite while being blindfolded. Not happening. So barcode scanner apps can help you with that, but there's one big problem. How the heck do you know where the barcode is on the product to begin with? And not only that, but then you need to line it up correctly. Anyone who has ever been to like the self-checkout counter at the grocery store knows how frustrating it can be. So we trained a CNN, showed it thousands of barcode photographs at different angles, lighting, sizes, resolutions, and then attached a beeping sound to it. The closer the barcode is, the more it beeps.
Process Coca-Cola 6CT.
The key learning here is that we often needed not just to solve a task, but to build another model to give guidance to frame the camera correctly. So a good input picture can then be passed on to the next task. And live feedback in few milliseconds on the device has been essential to this success. In the currency mode, we trained the app to purposefully remain silent if the user is too close to a currency node, partly because of blurry input and dark inputs. So the user started to learn to keep the node at least 6 inches away, and eventually it became a habit. Users would get instant results. And this led to higher precision too. In fact, the app purposefully never asks for ratings so that it doesn't interrupt the user's experience, which is primarily audio based. To share an example of something that's really tricky to pull off is conversations mixed with taking photographs on a cell phone. We all love visual question answering. We probably love visual dialogue, and that experience sounds simple. But let's see what happens when we try it in the blind community. Well, people know the general area of the photo they intend to take, so they bring the photo close to give a clear voice command. Then they take the phone back, elongate their hand, and in a few seconds it might take the photograph, right? But in that act of trying to do this, they often lose the framing of the photograph and often get blurry input and potentially not even the input they wanted to. This makes conversation-based interfaces to taking photos really tricky. This might work for a smart glass, but not for a phone. And for that reason, in Seeing AI, we resorted to using the screen reader and manually using their hands to select a particular mode. In a sense, human-computer interaction is of utmost importance along with the technology that can empower that intelligent experience. While building apps over the years, you get to see some technical trends. For example, we consider smartphones to be resource-constrained devices. Sure, if you're talking about a phone in 2010, 15, but not for 2020. The iPhone 11 Pro was more powerful than a MacBook Air. In fact, the iPhone 12 Pro can do 11 trillion operations per second. It has 16 cores specifically for accelerating neural computations. Resource constraint is not the word that comes to my mind. Now, talking about storage considerations, a ResNet 50 is about 95 MB. Imagine if you ship 3 less than 50 models, that's like already getting close to 300 MB. Now imagine every app started to do that. Your phone will just fill up with app storage. Instead, what Apple is doing is they are shipping the backbone of some of these models, like the ResNet 50, inside the OS itself. So you just have to ship the final task-specific dense layers, right? Reducing the amount of storage. In fact, if you use the Create ML GUI tool for doing transfer learning for your problem, you can ship models which are as small as 100 KB, after quantization. So you don't have to ship the full model, just the task-specific layers to get the job done. Finally, talking about energy consumption, we say neural networks will take a lot of energy. That's true, but only if you're doing it on every frame available. If you reduce your frame rate from 30 frames per second to say 1 frame, if you just have to do like 1 pass to do a VQA operation, you could be saving 1/5 of the energy by reducing that power consumption. So there is hope by deciding how your UX will be, and if the UX doesn't need it, why waste energy? One question people would ask is, which devices should I be supporting? So if you ship an app in the market and you want to cover 95% of the devices, it needs to take care of phones for the last 4 years. What that means is some of the real-time UI, if you want to cover 95%, you need to make sure that the phone 4 years ago would still be able to give a real-time frame rate like maybe 10 frames per second. If not, maybe you try to give graceful degradation by saying either a no to that feature or doing the inference in the cloud. Now, many AI capabilities are still a bit rudimentary, and there's just so much more to do. So how do we fill that gap? With the human power of Ira. Ira is an app that connects blind and low vision users to a professionally trained remote human agent. The agent can see a live streaming video from your smartphone camera and is able to thus describe your visual world. So users get access to visual information, except in spoken words, anytime on demand. And people have been challenging stereotypes when they get access to this visual information. This is going to be fun. We had a blind painter who got feedback from the agent after every brushstroke and ended up painting the Eiffel Tower. We have a blind cornhole player, Greg Stilson, who makes some pretty precise shots. He even took it up a notch and then became a blind driver. He's wearing these smart glasses which are transmitting data at low latency, about 80 milliseconds, so the same rate as what one would get if they were a first responder. 2 medical studies proved that users started to develop cognitive benefits of using such a service like Ira. As people saw new challenges, they developed inner confidence that whatever be the situation, whatever be the challenge, they would be able to figure out how to get it solved independently. And that's pretty amazing. This led to some incredible results. About 300 people got their first-time jobs in life. It reduced the dropout rate in universities down to single digits. And it has helped people finish over 500,000 tasks. So that's pretty neat. Now, why talk about this at CVPR? Well, we started finding opportunities to assist agents who are assisting users by overlaying helpful information relevant to the task at hand. For example, when navigating a user to a Starbucks, we started overlaying an augmented reality view on the screen of the agent to make them more productive, show them the directions to that Starbucks in their world. One time, my friend Greg Stilson, who's the inventor of the most used Braille tablet, had to give a conference keynote. And half an hour before, he couldn't find a shoe. So he called an agent and they kept searching and searching and searching. Ultimately finding it behind the curtain. So Greg asked me, can we navigate to an object of interest automatically? So we took the video, took each individual frame, and generated a 3D structure using structure from motion. We again took the 2D frames, ran object detection algorithms on it, and then raycasted it back into the 3D world, figuring out what is the plane of the surfaces in it. And so our 3D world is now labeled. And question is, can we do it for a bigger location? Yes, we can. At a retail partner location, this crowdsourced 3D map was generated by 3 willing blind participants who shopped at a store with the goal that the next users who will walk into that store will automatically get localized and then navigated to a location of interest. The big bold text banners that you see on top in retail stores turn out to be not just great for giving semantic information, but also like great markers for localization. So that's neat. Now, I'll leave you with one last demo. It's a personal project about building a virtual guide dog. When you're walking towards a millennial who is busy looking at their cell phone and is probably about to collide with you, you go ahead and dodge them. Well, that's how humans behave. Similarly, when your GPS navigation app says destination reached, the building is to your left. You don't just stop there. You turn to the left, find the door, walk towards it, find the handle, and then open it. That's how humans behave. Similarly, when traffic light turns red, we stop on the sidewalk. When it turns green, we start walking towards it. If we want to guide a person automatically on this particular logic, we would have to first build a traffic light detector, a lane segmentation system, a person detector, many other things. Then build rules on how to navigate dodging all the obstacles around it as the people come walking towards it. The amount of data to label and the number of items to teach, even for the simplest of tasks, would lead to death by 1,000 cuts. Instead, how about we find some form of self-supervision? How about we take an egocentric video, say from a cell phone kept in a lanyard, use either the accelerometer or use SLAM to find the camera poses over the video's period, and then use the previous X seconds of video to predict where the camera's location will be in the next Y second. So all we need to do is collect tons and tons of egocentric videos of people behaving and then train it. And then this starts to happen. The moment the red light turns green, we can predict that 2 seconds in the future, the person will be walking straight. 1 second in the future, the person is still stopped because humans have a normal reaction time to visual input. Or when the millennial walks towards you, the model can predict you will be turning slight right and then left 2 seconds in the future. That's pretty incredible. Now, if your GPS navigation app could give you high level directions like go straight for 200 meters, and the smartphone app analyzes video on the ground to give you more granular feedback based on the current sidewalk conditions, we could have your own virtual guide dog. The beauty here is that by supervising from video motion with enough data and patterns, the system would start learning what parts of the video to pay attention to on its own. This is a sneak peek here, but our aim is to publish an open source dataset, code, and a roadmap so everybody can try it out. To end, if I had to give some summary of the learnings from these experiences building things, it would be the simplest of the things can have the greatest impact. So it's not always the latest in technology, but something that is usable. And obviously, usability is important. Technology comes after. Attract your ideal users to be not just your tester, but actually make them part of your team, make them developers, researchers. They will have skin in the game and probably they want the technology more than you. Convey realistic expectations to users, under promise, over deliver. Make your research reproducible quickly if you want to get faster. So release your datasets in TensorFlow datasets and the code and collab notebooks so people can try the stuff out in 3 minutes or less. And finally, if you want to make really good impact, like impact that actually gets used, Contact Microsoft, contact Google, Seeing AI team, look out to put your open source research into production using them. Or, you know what, just contact me and I'll get you in touch with these people. So, in summary, technology is a great equalizer. It can level the playing field for everyone, filling one gap at a time. Thank you.